we have a little prompt for you called the problem of the day. Let's see what we've got for today's problem. It says here we have points A, B, and C that are collinear. That means they lie in a straight line, my friends. If AB equals 5, BC equals 20, and AC equals 15. You say, what in the world is that about? That means the distance from A to B is 5, distance from B to C is 20, and the distance from A to C equals 15. Sometimes we think that means multiplication. It does not mean A times B or B times C or A times C. Again, AB equals 5. That's the length. The length of BC is 20 and AC is 15. What we would like to figure out is which point is between the other two. Wow, okay. Sounded like a mouthful, didn't it? Now, as you're thinking about this, let's make a little bit of common sense. First of all, a picture I think will help a lot. So let's just draw a picture out of what this should look like. It's not a difficult one. It's a line segment. So we'll make a line segment happen here. There we go. And it has endpoints because it is a line segment. So we don't put arrows on here. This isn't going on forever and ever more in which direction and such. Now, the question is, which point is between the other 2 points? In other words, we're going to get a position here. Now you've got 2 possibilities. Once we figure out what one is in between, the other 2 could switch places, obviously. But we're going to specialize, we're going to specify, we're just going to put it together. How's that? Not necessarily alphabetically, because 3 letters, they don't have to be alphabetical. We're going to find out. So everybody thinks, well, B is between A and C, right? Because that comes, well, let's take a look. We've got A at AB, that length is 5. And I want you to notice AC, the length is 15. There is a relationship between the 5, the 15, and the 20. If you'll take a look at those, if you were to add 5 and 15, you will come up with 20. That's the whole idea of betweenness, we call it. Sometimes called the segment addition postulate. That's what we're going to call on, we're going to invoke here. So we want to make sure that we can say, we know for a fact that if we take 5 plus 15, we get 20. You say, well, duh, that was easy. It is. It is. Now, what we're going to do is we're going to, right underneath here, we may need to drop out the lower third, guys, is we're going to put AB because that corresponds to the 5. We're going to also put AC, which corresponds to the 15. Then we've got BC out here that corresponds to the 20. Now, what this tells me, what this just told me here, very simply, and it really is a simple concept. So when we look at this problem of the day, it looks intimidating at first, but once you see how this works, oh, it is really, it's very, very, very easy. This tells me right off the bat here, this is my longest piece. In other words, these 2 smaller segments are going to add up to give me the longest one. So this is my B, and there's my C right there. Already. So no, the answer is real simple. It's A. But let's go ahead and finish the picture. Let's go ahead and finish that picture. We are told that AB is going to be worth 5. So that's from here to here. And the other guy, little from A to C, is 15. Now what do you notice? 5 plus 15 will give you the whole length of 20. Whether centimeters, whether millimeters, inches, yards, whatever. That is what we call the segment addition postulate in many textbooks. Others call it definition of betweenness, because once you figure out where the point is that's in between, for example, in this case, we're saying that A is between B and C, then what has to be true? That AB plus AC will give you the entire length BC. That only works because they're collinear. There's no space lost. You got 5 units here, you've got 15 units here, you're walking, you're going to walk 20 total. That's the deal. That works because they're collinear. Now, if they were not collinear, then we have kind of a triangular situation, and that's a whole different ballgame. In fact, it becomes an inequality when you try to add these 2 pieces together and get to BC. It's no longer a equals to situation. These 2 would add up to be less than that third piece of information there. So that's an interesting point. That's a twist moment there, but that's what we call triangle inequality, and this is just simply a little bit of common sense. Two small segments should add up to give you the bigger segment if they are collinear. If they are laying end to end, their length plus that length will give you the length of the big piece. And that's our start. There's our problem today.